Welcome to our guide on mastering data management in Stata. This presentation will cover the essential skills of sorting, appending, and merging datasets. We will focus on providing a comprehensive guide to the append and merge commands, which are fundamental for preparing data for any serious econometric analysis. As the quote suggests, data preparation is a critical and often time-consuming part of research. The quality of your analytical output, such as regression models, depends entirely on how well you structure your input data. Imagine you have yearly survey data in separate files for 2022 and 2023. To analyze trends over time, you first need to combine them into a single, unified dataset. This presentation will show you exactly how to do that efficiently. So, why is combining data so important in the first place? Let's look at the common problem of fragmented data sources. In research, data often comes from multiple, fragmented sources. For example, you might have individual wage data from a labor force survey, macroeconomic indicators like regional GDP in an Excel file, and supplementary survey waves in a CSV file. Each file provides only a piece of the puzzle. To perform comprehensive analysis, like running a regression of wages on GDP, we need to bring this information together. The ultimate goal is to transform these separate files into a single, cohesive analytical dataset, such as a panel or cross-sectional dataset. This unified matrix is the required format for most statistical software, including Stata. To study the effect of regional economic growth on individual wages, you cannot analyze the labor force survey and the regional GDP data separately. You must combine them so that each individual's record also contains the GDP of the region they live in. Given that we need to combine data, the next logical question is, which method should we use? Let's explore the decision-making process. This decision matrix helps us determine whether to use the append or merge command based on our data manipulation objective. The core question to ask is, what is your objective? Are you looking to add more observations or more variables? If your goal is to add more observations, or rows, to your existing dataset, you should choose the append method. Think of this as vertical growth, stacking data on top of each other. For example, adding 2024 data to a dataset already containing 2023 data. If your objective is to add more variables, or columns, to your dataset, then merge is the command you need. This represents horizontal growth, linking datasets side by side, such as adding GDP data as a new column to existing worker data. A crucial step for both appending and merging, highlighted in the center, is to sort data, which is often a required prerequisite for these operations to function correctly and efficiently. Remember, knowing the precise shape of your desired output, whether it's more rows or more columns, is truly half the battle in successful data management. In Stata, the physical order of rows in your dataset matters for many commands. The sort command is the primary tool for organizing your data. By default, sort arranges the data in ascending order based on the variable or variables you specify. This is the most common use case. For descending order, you can use the gsort command. For example, gsort-varlist sorts the data in descending order of varlist. This is useful for tasks like finding the top 10 observations. A critical best practice is to always sort by a unique identifier, like a person ID or a firm ID whenever possible. This ensures reproducibility and what is known as a stable sort. If you have a dataset of students and you want to process them by their unique ID, you would use the command sort student ID. If you wanted to see which students had the highest test scores, you would use gsort-test score. Now that we understand the importance of sorting, let's look at our first method for combining data, appending. Appending is the process of stacking one dataset below another. You start with a master dataset in memory and append a using dataset from your disk. The most critical rule for appending is that the variable names in both datasets must match exactly. Stata is case-sensitive, so year is different from year. Data types must also be compatible. You cannot append a string variable, like provid stored as text, onto a numeric variable, like provid stored as numbers, without issues. If there is a mismatch in variable names, Stata will not produce an error. Instead, it will create separate columns for the mismatched variables, resulting in many missing values, which can corrupt your analysis. For example, if you have data 2022.dta with variables ID, wage, and year, and you want to append data 2023.dta, but the year variable in the 2023 file is accidentally named year, lowercase, after appending you will have two columns, year and year, each with half its values missing. Merging is the process of adding variables, columns, to a dataset from another, based on a shared key variable. Think of it as linking two puzzle pieces together. The master data is the dataset currently open in Stata's memory, while the using data is a file on your disk. The key variable is the cornerstone of any merge operation. It's the variable that exists in both datasets and is used to match observations. For a successful merge, the key variable must have the exact same name and the same data type in both the master and using files. Even minor differences in spelling, like Hanoi versus Hanoi, will cause the match to fail. For example, you have a master dataset with student ID and test score. You have a using dataset with student ID and parent income. By merging on the key variable student ID, you can add the parent income variable to your master file for each student. A one-to-one merge is used when the key variable is unique in both the master and using datasets. For example, matching student data with unique student IDs in both files. A many-to-one, M-to-one merge is very common. This is when the key variable is repeated in the master data but is unique in the using data. For instance, matching many students, master, to their one school, using. A one-to-many, one-to-M merge is the reverse, where the key is unique in the master but repeated in the using data. For example, matching one hospital, master, to its many patients, using. It is crucial to always explicitly specify the merge type, one-to-one, M-to-one, or one-to-M, and never let Stata guess. You should also avoid many-to-many merges, as they are often statistically ill-defined and can lead to ambiguous, incorrect results. To add regional GDP to a dataset of thousands of workers, you would use a many-to-one, M-to-one merge. The region ID key appears many times in the worker master dataset, but only once for each region in the GDP using dataset. Understanding these relationships is key to using the commands correctly. Let's now dive into the specific Stata syntax for both append and merge. The basic syntax for appending is append using file name. This command takes the dataset specified by file name and adds its observations to the end of the dataset currently in memory. A highly recommended option is generate new var, creates a new variable that flags the origin of each observation, typically with a 0 for the master dataset and a 1 for the using dataset. This is invaluable for verification. The force option can be used to append datasets with mismatched data types, for example, a string and a numeric variable. However, this is dangerous as it will result in missing values for the mismatched variable. It should be used with extreme caution. To combine two survey years, you would first load the 2022 data, then append the 2023 data. The command append using survey 2023.dta, generate source year, will combine the files and create the source year variable. You can then check your work with tab source year to see how many observations came from each file. This slide provides a detailed look at the syntax for Stata's merge command, which is essential for combining datasets by adding variables. The general structure is merge, tripe, var list, using, file name, comma, options. Let's break down each component. First, tripe refers to the merge relationship, such as one-to-one for one-to-one, m-to-one for many-to-one, or one-to-m for one-to-many. Next, var list specifies the key variable or variables that Stata will use to match observations between the datasets. Following that, the using file name part indicates the file on disk that you want to merge with your currently open master dataset. Remember, the master dataset is always the one you have open in Stata's memory, while the using dataset is the file you are culling from disk. Finally, comma options allows you to add various functionalities, such as keep using to select specific variables from the using file, generating to rename the merge result variable, or other options we discussed previously. A critical check to always perform is to ensure that your using file is saved and that the path to it is absolutely correct to avoid common merge errors. The Keep Using varlist option is extremely useful for efficiency. It tells Stata to load only the specified variables from the using file, which saves memory and keeps your dataset clean, especially when the using file has hundreds of variables. For instance, do you really need all 500 variables from the using file? Probably not. An example command is merge m1id using file2.dta, keep using GDP population. The Generate New Name option allows you to rename the default result variable, which is _merge. This is helpful if you are performing multiple sequential merges and need to keep track of the results from each step. The Update option is powerful. It tells Stata to replace missing values in the master dataset with non-missing values from the using dataset for matched observations. Finally, No Generate tells Stata not to create the _merge variable at all. This is generally not recommended, as checking the _merge variable is a crucial diagnostic step. The first and most important step is preparation. Remember the principle: garbage in, error out. The success of your merge depends entirely on the quality of your key variables. First, check your identifiers. You must ensure your key variable uniquely identifies observations where it's supposed to. The isID command will return an error if the variable is not a unique identifier. The duplicates report command shows the distribution of duplicate values. Second, standardize names. The key variable must have the exact same name in both the master and using datasets. If they are different, use the rename command to make them identical before merging. The golden rule is to never merge until you are sure your key variable uniquely identifies observations in the relevant dataset. Stata will stop you if there are issues, but checking first is always better practice. Now we execute the merge. Let's consider a scenario where we are merging individual-level labor force data with regional-level GDP data. The workerdata.dta is our master dataset, containing many workers. The regional GDP.dta is our using dataset, containing one entry for each region. The key variable that links them is region ID. Since many workers live in one region, the region ID is repeated in the master file, but is unique in the using file. This is a classic many-to-one, M1, relationship. The command is therefore merge M1 region ID using regional GDP.dta. If you mistakenly tried a one-to-one merge, Stata would produce an error because the key variable region ID is not unique in the worker dataset. First, you open the worker data with use workerdata.dta, clear. Then you execute the merge command, merge M1 region ID using regional GDP.dta. This will add the GDP information from the regional file to each worker's observation based on their region ID. The command has been executed, but our work isn't done. The next step is crucial, interpreting the output to see if the merge was successful. After every merge, Stata creates a variable called merge. This variable is your primary diagnostic tool. You should always inspect it immediately using the tab merge command. A value of merge equals 1 means the observation came only from the master file and did not find a match in the using file. This could indicate missing GDP info for a region. A value of merge equals 2 means the observation came only from the using file and did not find a match in the master file. This might be a region with no workers in your sample. A value of merge equals 3 indicates a successful match. These are the observations that now contain data from both the master and using files. Your goal is to maximize this category and understand any non-matches. If tab merge shows 3 observations where merge equals 1, it means 3 workers in your master file have a region ID that doesn't exist in your GDP file. You need to investigate why. Perhaps a region code was mistyped.
After diagnosing the results, the final step is to clean up the dataset and prepare it for analysis.
The first cleaning step is to investigate any unexpected non-matches. For example, you can use list region ID if merge equals 1 to see which specific regions in your master file fail to find a match. This helps identify data entry errors or missing information in your using dataset. Next, you typically want to filter your data. For most analyses, you are only interested in the successfully matched observations. The command keep if merge equals 3 will drop all non-matched observations, keeping only the intersection of the two datasets, ensuring your analysis is based on complete records. Finally, you must clean up by dropping the merge variable. Stata will not allow you to run a second merge command if a variable named merge already exists. It's good practice to drop it as soon as you are done with your diagnostics and filtering, so your dataset is ready for any subsequent data management tasks. This ensures a clean and efficient workflow. Let's quickly recap. Use append for vertical growth when you are adding more observations or rows. The key requirement is that variable names must be identical. Remember that errors in appending often lead to columns with missing values. The syntax for append is append using file. Use merge for horizontal growth when you are adding more variables or columns. The key requirement is a shared key variable with the same name and data type. Remember that errors in merging are typically related to non-unique keys or mismatched identifiers. The syntax for merge is merge one-to-one key using file. Finally, always remember the importance of reproducible research, which demands code-based data management. Avoid manual copy-pasting in Excel. Instead, script all your merges and data manipulation steps in a do file to create a permanent and transparent audit trail for your work.